So this is our problem now. So we'll find the nth derivative of x e to the power of 2x sine 3x cos 4x. Okay. And now let us concentrate on sine 3x and cos 4x. Okay. So this can be written as half of sine 7x minus sine x. Let us solve this. Okay, so x e to the power of 2x. Okay, so it's multiplied into 1 by 2. Let's keep it outside. So this is sine 7x minus sine x, right? Now let us take x by 2 and we'll put e to the power of 2x sine 7x minus e to the power of 2x sine x. Okay, this will take as u and this as v. Now, since we have taken u as x by 2 and v as e to the power of 2x sine 7x minus e to the power of 2x sine x. Okay. Now, we will find u1 here. u1 will be 1 by 2 and u2 will be 0 for this. Okay, that is for n greater than or equal to 2. Okay. Now, let us consider Vn. Okay, that is Tn of e to the power of 2x sine 7x, okay, minus Dn e to the power of 2x sine x. Okay. That is a is 2 square, so it will be 4. Okay, b is 7 square, so that will be 49.
49.
And to the power of n by 2, right? And
Yes.
e to the power of 2x, right? Now this is sine of bx, that is 7x, okay, plus n
0
tan inverse b by a 7 by 2,
by
okay,
2.
minus we have 4 plus 1, okay, 1 square, which is 1, n by 2 e to the power of 2x sine bx, which is x, and tan inverse b by a, which is 1 by 2. Okay. Okay. Now, since this is vn minus 1 would be 4 plus 49 to the power of n minus 1 by 2. Yeah? And sine
Sine
x
x
plus n minus 1 tan inverse 7 by 2, right?
yes.
Minus 4 plus 1 n minus 1 by 2, right? E to the power of x.
Yes.
Okay, e to the power of 2x. Don't forget that. Okay, e to the power of 2x sine x plus tan inverse. This is n. Okay. So n minus 1. Tan inverse 1 by 2, right?
Yes, sir.
So this is done. Okay. Now let us put all the things which we have un, u, and vn together. Now the formula becomes u vn plus nc1 into u1 v n minus 1 plus 0. Okay. The rest all the terms becomes 0. Okay.
Yes, sir.
Now let us substitute all the things. Okay. Now, since you have noticed that e to the power of 2x is common, right? I can bring it down, that variable, that exponential function, I can take it out. Okay, so this becomes, and also we have half, which is also common. Okay, x into e to the power of 2x, right? So 49 plus 4 gives out to be 53
53.
n by 2, right?
Yes,
And
sir.
sine 7x plus n tan inverse 7 by 2, right? Okay. And now this will be negative, right? Negative. 4 plus 1 is 5, power of n by 2. And this is sine x x plus n tan inverse 1 by 2, right? Was it?
Yes, sir.
And we have one more term, this plus nc1. What is nc1? N, right?
Yes, sir.
And u1 is 1, right? So n into 1. Okay. So again, e to the power of 2x, which is common. Okay. Again, 53, right? We write down this and this. 53 n minus 1 by 2, right?
Yes, sir.
And sine 7x plus n minus 1 tan inverse 7 by 2, right? Okay, and 5 to the power of n minus 1 by 2 sine of x plus, now this will be again n minus 1, tan
Yes,
inverse
sir.
1 by 2, right? So close it. So this will be the solution. Okay, this will be the
Yes,
nth
sir.
derivative. Let us find the nth derivative of this. So let us consider this as u and this as v. Okay. Now this would be un is a power n e to the power of ax, right? So vn will be minus 1 to the power of n minus 1, okay, and n minus 1 factorial by x plus 1 to the power of n. So now by using Leibniz theorem now, okay, so we have to
Yes, sir.
find dn of e to the power of ax log of x plus 1, that's correct, which is u into v nth derivative, right? Let us write the general formula. Summation x is equal to k is equal to 0 to n, nck, okay, and uk and v n minus k. Okay, this is the general term. Okay, now let me put that. Okay, so k is equal to 0 to n, right? 0 to n. So n c k. Now un or uk will be a power k e power ax, right? And v n minus k. So that would be minus 1 to the power of n minus k minus 1, right?
Yes.
And n minus k minus 1 factorial by x plus 1, right? And this would be n minus k. Yeah. Now let us put the values of k being 0, 1, and so on, right? So for k is equal to 0 and the summation, right? Now what you observe this as e to the power of ax is common. So like let us take that outside. Okay. So this would be minus 1 to the power of n minus 1. Okay. Since k is 0, this would be n minus 1 factorial, right? Divided by
Yes, sir.
x plus 1 to the power of n, because n minus k, which is 0, right? Now, since this is summation, you have to put plus sign, okay? Yeah. The next term would be minus 1 to the power of n minus 1 minus 1, right? Okay.
Yes, sir.
So that would be 2. Okay. Let me put down n minus 2, right? And this would be n minus 1 and minus 1, that will be 2, right? Divided by x plus 1 to the power of n minus 1, right? And we have nc1, okay?
Yes.
nc1. nc1 is nc1 would be n, okay? nc1 would be n, okay? Plus now nc2 will be n into n minus 1 by 2 factorial, okay? And also don't forget a here, okay? A power 1, right? K is equal to 1, okay? Now k, a is 2, so a square, k is 2, so a square, and multiplied into minus 1 to the power of n minus 3 and n minus 3 factorial by x plus 1 to the power of n minus 2.
Yes.
Okay, and still it continues to add up. So this would be the last term, n into a power n minus 1 by x plus 1, okay, and plus a power n log of x plus 1. So this will be the final value, final term. So let us prove this. Now, first, we have to notice that the log of m by n, okay, can be written as log m minus log n. Okay, let us write that. So log of this would be x minus 1 minus log of x plus 1. Now we'll consider this as u and this whole thing as v. So u being x, so u1 will be 1. Okay, for n greater than or equal to 2. Now v is log of x minus 1 minus log of x plus 1. Vn is dn of log of x minus 1 is dn of log x plus 1, right?
Yes.
Now let us solve further. Yeah. Okay. So further, now Vn is minus 1 to the power of n minus 1, okay, and n minus 1 factorial by x minus 1 to the power of n, okay, minus, this is for log of x minus 1, okay. Now for x plus 1, so this would be minus 1 to the power of n minus 1, n minus 1 factorial by x plus 1 to the power of n, okay. Now further, now we can take minus 1 to the power of n minus 1, which is common, okay. Also we have n minus 1 factorial, which is common. So this would be by x minus 1 to the power of n minus 1 by x plus 1 to the power of n, okay. Now, therefore, by Leibniz theorem, what do we have? Yn, which is dn of x log of x minus 1 by x plus 1, right? So that would be u into v, right? u vn plus nc1, right? And u1 vn minus 1. And don't have the next terms. Okay, let us substitute. So we got u as x, right? And vn as this whole thing, right? So let us substitute. So minus 1 to the power of n minus 1, n minus 1 factorial, okay, into by x minus 1 power n, x plus 1 to the power n, right? Plus
Yes. Yes, sir.
nc1. nc1 is n, right? And u1 is 1. Now let us substitute n minus 1, right? So we have minus 1 to the power of n minus 1 minus 1. That will be n minus 2. Okay, so this is also n minus 2 divided by 1 by x minus 1 to the power of n minus 1 and 1 by x plus 1 to the power of n minus 1, right? Okay. Now, if you would observe here, we can take minus 1 to the power of n minus combining together, okay, as common.
Yes.
Okay, so let us simplify further. We get as this will be over n, okay? And this will be n minus 2 factorial. So further, let us take this common. This will be x minus 1 to the power of n, okay, and this is minus x into n minus 1 plus n into x minus 1, right? Close the brackets. So minus 1 by x plus 1 to the power of n. Open the brackets. X n minus 1 plus n x plus 1. Okay. And finally, we get on the right hand side, we get as minus 1 to the power of n, n minus 2 factorial. This is x minus x minus n by x minus 1 to the power of n minus x plus n divided by x plus 1 to the power of n. So this is, so hence we have proved it. Okay.
Yes, sir.
If y is equal to x square e to the power of x, okay, let us prove that yn is equal to 1 by 2 n into n minus 1 y2 minus n into n minus 2 y1 plus 1 by 2 n minus 1 into n minus 2 into y. Okay. So we know that y is x square e to the power of x, right? Now y1, okay, which would be x square, differentiation of ex is ex, okay, u into a, okay. This would be 2x, okay, differentiation of x square will be 2x, and this is ex, okay. Let us put this together. Now we know this result, this as y plus this is 2x e to the power of x. So your y1 will be y plus 2x e to the power of x. Now let us find y2. Now this would be y1, okay, and let us see about this. So this will be 2x into e to the power of x and 2 into e to the power of x. Now 2x into e to the power of x we can write as y1 minus y, okay. So your y2 will be 2y1 minus y plus 2 e to the power of x, okay. yn will be now since we have up to 2, right? So that would be u1, that is e to the power of x, right? X square plus nc1, okay, e to the power of x, and this will be 2x, right? And this will be nc2, okay, by Leibniz nc2, and this will be e to the power of x, and this is 2. Okay, you got yn. Now yn will be x square e to the power of x plus nc1 is n, so we'll take n 2n into x e to the power of x, and nc2 will be n into n minus 1 by 2 into 2 into e to the power of x, or yn will be written as x square e to the power of x into nx e to the power of x, and n into n minus 1 e to the power of x, right? Now let us substitute for x square e to the power of x and 2x e to the power of x, okay, and e to the power of x. Okay,
Sir.
yeah, so you get yn. So x square e to the power of x would be y plus now 2x e to the power of x will be, tell me, that is n into y1 minus
Why?
y, yeah, plus now this will be n into n minus 1 by 2 into y2 minus 2y1 plus y, okay,
Yes, sir.
sorry. So this will be, now let us simplify this. Further, so this will be half, if I put everything together, okay, into n into n minus 1 y2, okay, minus n into n minus 2, right, into y1 plus half n minus 1 n minus 2 into y. So we got this. So hence we have put